In this question, Robert has $300 in his wallet, and it's known to be in $50 or $20 notes. And we're asked what are the possible numbers of each type of note. So first off, we can recognise this as a linear Diophantine equation. And we know that they are in the form ax plus by equals c. So let's start by letting x be the number of $50 notes and y the number of $20 notes. So we can rewrite our linear Diophantine equation as 50 times x, where x is the number of $50 notes, that'll give the total value of the $50 notes, plus 20 times y, and we know that the total amount in his wallet is $300. The linear Diophantine equation needs us to work out the highest common factor between a and b, where they are the coefficients of the x and y in a linear equation. So the highest common factor of a and b is the highest common factor of 50 and 20. And now hopefully you can see just by inspection, because they're pretty small numbers, the highest common factor of both is going to be 10. We also need to find one integer solution, x0, y0, which satisfies the linear equation. So one possible solution you might be able to find is x is 2, which gives it $100 in $50 notes, and the remaining 200 is 10 times $20 notes. So one solution could be 2, 10. So next up we need to just plug in our values to our general solution. So we know that x is equal to x0 plus b on d times t. Y is equal to y0 minus a on d times t, and t is going to be an element of integers. Substituting in the values of x0, a, b and d, we can find that the general solution to this equation is x equals 2 plus b on d, which is 20 on 10 times t, y equals 10 minus a, which is 50 on d, which is 10 times t, and t is an element of the integer set. Cleaning this up, we can simplify it down to x equals 2 plus 2t, y equals 10 minus 5t, and t is an element of the integer set. Once again though, we've got a real world context where we need to take into account we can't have negative amounts of either note. So we can only have positive amounts of $50 and $20 notes or 0. So this graph shows the linear Diophantine equation with the integer solutions indicated along the line. The green point at 2, 10 was the single solution that we found before, x0, y0, and before we had that x equaled 2 plus 2t, y equals 10 minus 5t, and t is an element of integers. However, we need to have a look and see what values of t we can let it go between. So as t is multiplied by 2 in the first equation, we can let it go 1 unit of t this way, or up to 2 units this way, before we'll get a negative x value. And you'll find that the same will hold for the negative 5t here. We can let it go one more this way or two more down before it will become a negative solution for y. So in that case we can write in set notation that the solution is the set of x comma y such that x is equal to 2 plus 2t, y is equal to 10 minus 5t, and t is an element of the set. And we can let it go between -1, 0, 1, and 2. And if you plug any of those values for t in, you'll still have a positive or 0 value of x and y, which is the number of $50 and $20 notes.